Hello, I welcome you all to this another interesting screencast. The problem reads, we already solved the first problem, the 12-176. 12-176 was already solved in the previous video. So we're going to the second problem, case 2, 12-177. And it reads, the car travels around the circular track such that its transverse component is theta is equal to 0.0060 to the power 2 rads, where t is in seconds. Determine the car's radial and transverse components of velocity and acceleration at the instant t equal to 4 seconds. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Right, so in this particular problem, we're going to use the polar coordinates. For polar coordinates are appropriate for this particular problem, but you can use whichever method you feel is okay. So we have the radial component in this direction like so. Okay, these are the positive directions, and then we have the transverse component in that direction like so. Right, so let's call this as theta, and then this one r. Okay, right. So like we said, this is case 2, which is 12-177. Right. Okay. So there we go. So what we have, so we know that here I've been asked to find velocity as well as acceleration, its radial and transverse components. So we know that velocity itself, okay, is equal to this is a scalar, okay, values. This is equal to Vr squared plus V theta squared, okay, where our Vr is equal to R dot and our V theta is equal to R theta dot, right? And then we know that our acceleration also is equal to AR squared plus A theta squared, right? And where our AR is equal to R double dot minus R double dot minus R theta dot squared, and A theta is equal to R theta double dot plus 2R theta 2R dot theta dot. So these are the equations. So what we have here, we have theta, all right, given as a function of time, okay, 0.0060 squared, all right, and therefore our theta dot, okay, which is time derivative of theta itself, this becomes equal to that's 0. This is let me just work it out, 0.006 by 2. So this just becomes 0.012 t. Okay, so this is just the theta dt, okay, right, which is just equal to 2 by 0.006 t. This is what we did, right? And then we also know that our theta double dot is just going to be equal to just 0.012. All right. Okay. Then we have R is equal to 400 cos theta. 400 cos theta. Maybe before, all right, we can go ahead. Therefore, r dot, again, r dot is just equal to the r dt. All right. It's a time derivative of the position vector. So this becomes equal to minus 400 theta dot sine theta. All right. Then r double dot is just going to be equal to, we factor out 400 and then product rule. So we have theta double dot sine theta, right, plus theta dot squared cos theta. Okay. All right, I think we've done everything that we need to do. So what we just need to do now is to replace t, which is equal to 4 seconds in our equations, so that we find a rm, a theta, vr, and v theta. Okay, so let's do so. So let's start with theta. So theta at t equal to 4 seconds, okay, just going to be equal to let's work it out. So we are using this equation here, this equation. All right, that's the equation. So let me just get this there like this. This is what we are doing right now. All right, so we have a 0.006 by 4 squared. All right, so this gives us a 0.096 rads. But of course, we need to convert this to degrees, and we know to say 180 degrees is equal to 1 radian. Okay, so let's use that. So we'll continue with this. We are just going to say times, this is times 180 degrees divided by 1 pi rad. Okay, pi rad. Simplifying this, rad and rad cancels out, and then we have 0.096 by 180 divided by pi. So 0.096 by 180 divided by pi. This gives us a 5.5004 degrees. We can put it there. So this is our theta in degrees. Our transverse component. So with this, we are able to find theta dot. Of course, we are using this here. Okay, theta dot at t equal to 4 seconds. What do we get? So 0.012 by 4, we get a 0.048 rads per second. This is rads per per second, right? This is rads per second. Let me see, that's 0.012 by 4. 0.48. Right. So we have the angular velocity theta dot 0.048 rads per second, and then we have the angular acceleration at t equal to 4 seconds, and this one is constant. It is 0.012 rads per second squared. So we are done with this. Let's work out error. Our error at t equal to 4 seconds. Okay. This is going to be equal to, of course, this we are feeding in theta, which is a function of t, and is 5.5. So we are using this one here. All right. So let's plug it in. So this becomes a 400 cos 5.5, and this we get a 398.16. All right, round it off. This is 16 meters, and then r dot. Okay, r dot. This is our radial velocity, right? So this, of course, we are using this equation here. Let's plug in all what we have. So we have minus 400 times theta dot, which we found as 0.048, then times sine theta, which is 5.5. So this we get, so at t equal to 4 seconds, this we have a minus 1.84 meters per second, right? Let me check it again. Minus 400 by 0.048 by sine 5.5. All right, minus 0.84. Then we have r double dot at t equal to 4 seconds. We are using this equation here. What do we have? Theta dot, we have 0.012 sine 5.5. Okay, right, plus theta dot squared as 0.048 squared times cos 5.5. Then everything times minus 400. Cos this we have minus 1.38 meters per second squared. All right, so we found everything. Let's plug them back in the equations. Let me just create boundary here, like so. There we go. Right, so what do we have? So let's start with our V error, and this is equal to r dot. Of course, this is the radial component of velocity, and this r dot we already found. This is a minus 1.84 meters per second. Then we have v theta, which is equal to r theta dot. All right, and then this, you know what r is. It's all these are values at t equal to, these are all values at t equal to, so at t equal to 4 seconds. Alright, so our error, we already found that is 398.16 times theta dot, which is 0.048. Alright, so this we find our error, we say it is 390, and then the other one, so this we find 19.11 meters per second. So error we said is 398.16 times theta dot 0.048. Okay, 19.11. All right, and then we have acceleration, which is equal to r double dot minus r theta dot squared. Of course, we have all these values, we just need to plug in. R double dot, we already found it is minus 1.38 minus R, which is 398.16 times theta dot squared, which is 0.048 squared. And this gives us a minus 2.30 meters per second square, and a theta, all right, which is equal to r theta double dot plus 2r dot theta dot. This is just going to be equal to r is 398.16 by theta double dot, which is 0.12, plus 2 times r dot, which is a minus 1.84, then times theta dot r dot, okay, minus 1.84, theta dot is 0.048. Alright, so this we find a 4.60 meters per second square. Let me repeat this one. R 398.16 by theta dot 0.12 plus 2 by r dot, which is minus 1.84, close bracket, times theta dot. The theta dot is 0.48. Alright, there we go. So we found the radial components, which we can outline. So we have the velocity, radial, and transverse component, and we have the acceleration, radial, and transverse component. Right, I think this is really about it, and I hope this video was helpful, and if it was, give me a thumbs up. Before I go, let me just show these components here. So we have VR, and like so. All right, V theta in that direction, like so. Okay, and then what else? AR in this direction, like so, and then A theta in that direction, right? So let's label them. This one is A theta, this one is AR, and this one is V theta, right? And this one is VR. Okay. All right. So I think this is about it. And I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.